Hey there, pre-calculus fans. We have been talking about composition in my class. That's plugging one function into another. And we've talked about various things, and the discussion ends with a talk about multipart functions. So this video is going to be about multipart functions, in particular how to do compositions of them, which is kind of a challenge problem, but I hope to give you a way to think through it. And in doing so, this reminds me of this thing I made up like 15 years ago called the Loveless lines of reasoning. But mostly this just gives you a better feeling for what a function is. So check this out. So the order does matter when you do f of g of x. The g of x on the inside, that's what you're plugging into first. And these are the Loveless lines of reasoning. And that's going to be different than if you plug into f first. So let's just run a little experiment using the graph on the other side. So if I plug in a 2 first and then do the absolute value of 2, I get a positive 2, and that's the picture you're seeing. When you plug in a negative 2, you get to, that's the V shape. Then if I plug that 2 into the other function, which you can see down below, so now I'll plug in a 2 to the other function, you can see the answer is negative 6. So what happened there is we did not flip. We just plugged in a 2. When you plug in the absolute value, you have to think about whether you flip or not. We didn't flip, and then we plug that into 3 times 2 minus 12, and that gives us negative 6. But that's exactly how you would find the rule for it. You just wouldn't call it a 2, you'd call it an x. If you think about the other direction, what happens if we plug in a 2? So if you plug in a 2 right away, and you plug in a 2 here, what's going to happen? Let's do that. So now we're plugging 2 into the function. We get negative 6. Then we're plugging negative 6 into the first function. So let me give you that picture. Just a moment. So now I'd like to plug in negative 6. So we go over to negative 6, which is way over here, and we get 6. That's a big difference. So the order does matter here. In fact, because this gives me negative 6, I actually have to flip it. How do we keep track of all this? So that's why years ago I just was like, well, we need to keep track of when we change. Sometimes we think of that as when we branch between two possibilities. It's actually really simple. So the only thing you need to know for this first example, and then I'll do several more examples, but for this first example is that the absolute value is a multipart function. It doesn't matter where the x is. It's just whatever you plug in here either gets flipped, or not flipped. And that just depends on whether it's positive or negative. So the moment we plug in the absolute value, we have to think about that. Okay, so here's all you have to do. You go, okay, I'm going to plug in my function. Since the inside is the absolute value, then I immediately have to think about, is it positive or negative? If it's negative, I flip whatever's here. If it's positive, I don't. Done. Then you plug that into the f function. So the next step is to replace this with whatever we're throwing in. And that's it. So we're going to replace it with either negative x, which is what we're going to do here, or we're going to replace it with positive x, which is what we're going to do here. In other words, we're going to replace it with flip or don't flip. We are done. So I wanted to start with a more basic example before I did more complicated ones. So the question students then have is like, well, how do I know what the branch points are? It's all in the Loveless lines of reasoning there. You can see it. You can just look at each branch and summarize. So what you would summarize and say, okay, do I want to write this function all at once? Sure. F of g of x has two different rules, and we can see back at the branch point where they are. They're when x is less than 0 or when x is greater than or equal to 0. And the final form at the end of the branch is negative 3x minus 12 and 3x minus 12. And you can plug in different numbers and see if that matches up with the two-step process. But the goal is to try to get it all to a one-step formula. Okay, so now the more interesting one. We saw that even though we plugged in a positive 2 here, we had to flip. Why was that? Because we weren't plugging that into the absolute value. So now we're going to play the same game. It's just we're going to put this into the absolute value. That's what's going in here. And that means all the things have to change. So the moment you plug into that, you branch. So every time you plug into a multipart function, you branch between two possibilities. Now in this case, the possibilities are going to be if 3x minus 12 is negative, or if 3x minus 12 is positive. And that means you're going to flip. So in this case, you would flip. And in this case, you would not flip. And we're done again. We've reached the end for each one. And we could summarize. We could say, well, g of f of x has two possibilities. One is this. I probably just feel like I want to simplify. The other is this. And those should be the formulas, but we need to then go and look at our conditions. So let me minimize these pictures for just a second so we aren't staring at them. Okay, so now you go back and say, well, it's not as easy for me to say this is the condition, but can I make that a little nicer? Sure, I can move the 12 over, divide by 3. This would be when x is less than 4. And this would be when x is greater than or equal to 4. And now you can see that example I did with the positive 2. Even though 2 was positive, when I plugged it in, I had to flip because 2 is smaller than 4. And if you plug in something smaller than 4, this was going to be negative. Okay, so that's kind of the overarching picture. I'm going to do another example, and then I might do a challenge problem in a different video. But this is so you can see the biggest difference was when did you plug in to the absolute value? Did you do it right away, which would be something like 3 absolute value minus 12, or did you plug it in after the fact? And I talked in class about how the first one we didn't change the input to x, that's why it was still 0. The second one we did change the input to the absolute value. Okay, let's do another one. So here's another one, another multipart function. The p of x is the multipart function. So let's play this game again. So let's say we plug into h first, and let's see what happens. So you plug into h, you add 5. Then you plug that into all of these spots. So that's changing the input. So now we branch. So we're going to plug into p, but whatever we're plugging in has to go in those spots. So there's two possibilities. You could even just write that we're going to do p of x plus 5 if that helps you. But that's the moment we have to branch. So two possibilities, and they depend on whether the input is less than -1 or greater than or equal to -1. And then we use the appropriate rule. So if it's less than 1, we use the top rule, but we replace. So we're going to do x plus, but maybe I should write it this way. We're going to do the top rule. Top rule is whatever you just input plus 10, or the bottom rule, which is whatever you input squared. So now let's throw in what we're inputting. We're inputting x plus 5, x plus 5, and then we're done. So I mean, with practice, this isn't that bad, but you can see it really forces you to think about what is the input, what's a function, what's the output. So that's the reason we do that. It gets you to really think about functional notation in a different way. So now we can say one formula is x plus 15. Another formula, and I would just leave it as x plus 5 squared. You could expand it, it wouldn't be marked down. And then I would say, well, the restriction is, now it's subtract 5. X is less than -6, or x is greater than or equal to -6. At that point, if you really wanted to check your work, you could go back to the beginning and just do a computation and compare. In fact, you'd even try -6, since you know that's kind of interesting, or you could try something else. So let's try one that maybe is easier. So let's say we wanted to do p of h of 0. So let's try it the long way, and then let's try it with the shortcut, and let's see if we get the same thing. So this is a check on our work. So if you use the shortcut, you go, well, 0 is bigger than -6, so I plug it into the second one. It's 0 plus 5 squared is 25. Okay, now let's do it in 2 steps. What is h of 0? H of 0 is 0 plus 5, which is 5. And then let's take 5 and plug it in to p. 5 is greater than -1, so it's going to be 5 squared. It's going to be 25. That's all we're doing. We're just learning to work with functions. All right. Let's get rid of that. So now let's try it again. So now we're going to plug into the p function. The moment we plug it in now, we have to branch. And we ask ourselves, what are we plugging in? We're plugging in an x. And so the branch is if x is less than -1, or x is greater or equal to -1. Then we know the rules. So what we're plugging in is x. So it's x plus 10. And again, this overshoots. Not very many places do problems like this in their pre-calculus course, but I think it really hits home the idea of what a function is. Then we're going to plug into the h function. This is going to be h of x plus 10. And this is going to be h of x squared. It's also just good to practice logical thinking. And the function for h is whatever you input plus 5. The function here is whatever you input plus 5. Here we're inputting x plus 10. Here we're inputting x squared. This gives me x plus 15. Sort of a coincidence that that matches. This gives me x squared plus 5. And now we're done. So we can summarize what that function is. I'm going to go just a little bit higher and say h of p of x is the following. It's x plus 15, x squared plus 5. And what are the branch points? Well, we can see them. X is less than -1. X is greater or equal to -1. Done. So there's the game. You can then try a number. I think I will in the next video do the challenge, which is what is the multipart rule for this? So the challenge here is there's a multipart inside of a multipart. What we just did was 2 examples where there was one multipart function. And we did it with the multipart function on the inside, and we did it with the outside. Notice that when it's on the inside, just to say this a number of different ways, the branch point happens right away, so it doesn't change. So you can see when the multipart function is on the inside, this doesn't change. When the multipart function is on the outside, the variable changes before you plug it in. So it changes how you branch. All right, let me know if that helps, and I'll follow up with a video on multipart inside multipart.